In this example, we're going to solve a system of linear equations in 3 variables using Gaussian elimination. And we're just going to get into triangular form and then do back substitution. Since it is 3 variables, this will take a little longer than the 2 variable videos, but bear with me and we'll get through this. So our goal using Gaussian elimination is to turn our matrix into an upper triangular form, which means I want to eliminate these two x's and eliminate this y, in which case I will now have an equation in 3 variables, an equation in only 2 variables, and an equation in 1 variable. This equation in 1 variable we can solve easily and then start back substituting into the other equations. So in order to do that, my first goal is to make the coefficient of this variable a 1. And we're already there. We were given an easy one. So the coefficient is currently a 1. Remember, there are only 3 things I can do. I can swap any 2 rows. I can multiply any row by a non-zero constant called a scalar. Or I can add any multiples of any 2 rows. So now that this is a 1, what I'm going to do is take multiples of this row that will eliminate these x's. And to save space in writing, I like to do these in a single step. So I draw an arrow that this will be my next system. And I start by saying I need to multiply row 1 by a -3 in order to eliminate row 2. So we're going to take -3 row 1 and add that to row 2. That's not row 2. Let's get an R2 here. Now the book will tell you this goes into the new row 2. I take this to mean that wherever we end is the place it's being put into. And then in order to eliminate this, we need to multiply row 1 by 2. So we're going to take 2 times row 1 plus row 3. And now, since row 2 and row 3 are the ones we see here, they are the only 2 that are changing. Row 1 stays the same, so we can just rewrite it as is. X plus 2y plus z equals -9. I apologize for some of my handwriting here. Well, I'm changing row 2. I'm changing it by adding -3 row 1 to it. And it's actually probably easier to think about it as row 2 minus 3 times row 1. So I'm going to take 3x minus 3 times x, which is 0x. We don't need to write that. We're going to take 4y minus 3 times this. Well, that's 3 times -2, so that's -6. We're subtracting a -6. It's the same thing as adding 6. So we've got 4y plus 6y is 10y. And then 5z minus 3 times z is 2z. And finally, 9 minus 3 times -9. Well, that's -27. Subtract the -27. That's the same thing as adding 27. So we have 9 plus 27 is 36. And now we go to row 3. It's also changing. We're going to add 2 times row 1 to it. So we'll take -2 plus 2 is 0. We don't need to rewrite it. 3y minus 4y. 2 times 2 is 4 is -y. And then -z plus 2z is +z. And then finally 12 minus 2 times this, or 12 plus 2 times -9, I should say. 12 plus -18 is -6. And so we have eliminated our x's. Our next goal is to get a 1y in this spot. And I could multiply this entire row by 1/10, but then we're left with a 1/5 z and, let's reduce that. What's that? 18/5 over here. That's a little ugly. Is there a better way? In this case, yes. This y already has a coefficient of almost 1. It's negative 1 instead of 1. But that's close enough. So we're going to swap these two rows. And so I write that with this, an arrow coming over here. We're going to take row 2, and I am going to swap it with, well, I want that to be a positive one, so I'm actually going to negate row 3. And I don't think I'll have quite enough room right here to write it, so I'm going to move down to the next line. Row 1 isn't changing. Row 2 and row 3 are switching spots, and row 3 is being negated. So it's now y minus z equals positive 6, and 10y plus 2z equals 36. And now my goal is to get rid of this y. Well, if I take this one and multiply it by negative 10, when I add it, they will go away. So what we're going to do is take negative 10 row 2 plus row 3. Row 1, again, isn't changing. Row 2 is not changing. That's an equals sign, I apologize. But row 3 is. We can think of it as this row minus 10 times this row. So that's 10y minus 10y is 0. We don't need to write it. 2z. Multiply this by negative 10, we get 10z. So 2z plus 10z is 12z. And 36 minus 60 is negative 24. Now the last thing I would want to get is I really want this to be a 1z, so we're going to take row 3 and multiply it by 1/12. Again, row 1 and row 2 don't change. But row 3, 1/12 times 12 is 1. 1/12 times negative 24 is negative 2. So that tells us z is negative 2. So what can we do with that? Well, right here we have just y and z related. So we're going to take that and plug it back in. So we know y minus negative 2 is equal to 6. But minus and negative 2 is the same thing as plus 2. So y plus 2 equals 6. Which means y equals 4. That's good to see. Let's scroll down a little bit. And now we've got this equation up here, which relates all three variables. We know z is negative 2. We know y is 4. So we'll go to that equation. We've got x minus 2 times 4. Put the 4 in for y. Put the negative 2 in for z. And we should get negative 9. I'm not sure what happened to my negative up here. So that means x minus, that's 8, minus 2 is 10, so x minus 10 is negative 9. Add 10 to both sides, we get x is 1. So we've got, whoops, that was supposed to go green, sorry. X is 1, y is 4, and z is negative 2. And since the solution to a system of linear equations in 3 variables is an ordered triple, we write it as 1, 4, negative 2.